Hello everyone! I'd like to talk for a few minutes about some graphs of common functions. It helps a lot when you're working with graphs to kind of be able to anticipate what a graph is going to look like before you even start plotting it out. So a linear graph, for instance, that's anything that follows this formula, y equals mx plus b, and it could be as simple as just y equals x, right? Could be that. That is just going to be a nice straight line. This is, in fact, the graph of y equals x, because whatever x equals, y also equals that. If x equals 3, y will equal 3. If x equals -7, y will equal -7. So this is a nice, simple linear graph. If you are graphing an absolute value function, however, like y equals the absolute value of x, you do not get a straight line. Instead, what you get is a V shape. Cool, right? I mean, you might not have known that before, but now that will forever change the way you see your absolute value signs, because you will immediately think to yourself, it must be a V on a graph. If you're graphing anything with a squared component, so the classic would be y equals x squared, in that case, you do not get a line, you do not get a V. Instead, you get a U. And that's what you get whenever you have an x squared. If you're doing x cubed, so y equals x cubed, then you get a very fun to draw kind of curvy S-shaped thing. Sometimes it's like an S, sometimes it's the reverse of an S, but you get this S-shaped thingamajig going on. And if you are graphing something that is the square root, so like y equals the square root of x, then you do not get a line, you do not get a V, you do not get a U, you do not get an S. Instead, you get a little curve like that. And if you're doing the cube root of something, which would be like y equals the cube root of x, then you get something completely different altogether. You get kind of a sideways S, like that, right? So you can see how very different all of these graphs look. And if you can anticipate what this is going to look like, then you'll know that you should be looking for some shape like this. Now, let me give you some more examples. So let's look for a minute at this absolute value function right here. Whenever we see absolute value, we're going to be expecting to see some sort of V shape. And what I have here is I have 3 functions for you. I have y equals the absolute value of x, and that's just our regular V. Here I have y is the absolute value of x plus 2, which is still a V, although it's in a different spot on the graph. And here we have y equals the absolute value of x plus 3, where all of x plus 3 is in the absolute value side. Yes, and you will see that you still get a V shape. Again, it moves places on the graph, but it's still a V. Now, I don't expect you to be able to look at these functions and tell me where it is on the graph. That will be for some later math teacher to make you crazy with. All I want you to know right now is that absolute value is always going to be some sort of V shape. All right, let's take a look at your squares. So remember, we said that the squared function is always going to look like some sort of U. Well, here's a couple of squared functions for you to look at. Here we have y equals x squared, which is just going to be our standard U. Here we have y equals x squared over 2, which again is a u. You might not notice this, but it's skinnier than this u. That's the difference, right? And here we have x squared minus 7, which moves our whole u down. Again, the point is not that you anticipate how the u moves. What I want you to remember, however, is whenever you have x squared, you should be thinking, oh, I bet it's going to be u-shaped. Let's take a look at cubes. Here are some cubed graphs, and you'll see that they are all the swooping S-shaped. Here's our classic, y equals x cubed. That's the S shape. Here we have x cubed plus 1, which is the S shape, but in a different spot on the graph. And here we have 5 minus x cubed, which gives us an inverse, kind of a reverse slope to this, but you could still see the S shape. So whenever you have an x cubed, you should be expecting some sort of swoopy S shape. Okay, let's take a look at some square root examples. So square roots, we said, were going to be this little curve. And you can see that even if I add 3 to it, I still get that curve. It touches a different spot on the y-axis, that is true, but that's what it is. And here we have it narrower, I guess. The slope is less than it is over here because we're dividing everything by 4. But no matter what, when you see the square root of x, you are expecting some sort in this slow shape, this slow sloping shape. And finally, the last one that we looked at were cube roots. And you can see that we have our sideways S. Again, it's moving places on the graph, but it's always the same basic shape. So what I would like you to do is I would like you to take a moment in your notebook, and I would like you to write these little samples for yourself so that you know, if I'm looking at a square root function, it's going to look kind of like this when I graph it. And if I'm looking at a squared function, it's going to look kind of like this when I graph it, and so forth. This is a very helpful tool as we spend more and more of our time graphing.